So I'm going to be talking about holographic displays. Holographic displays are those that use light diffraction to create a virtual 3D image of an object. They are unique because most do not require wearing any special goggles. This is a quote I thought was interesting. While everyone is fixated on AR using smartphones or headsets, the real hologram revolution is emerging from the lab. So a few benefits. Enable interaction with objects. Like you see here, a person interacting with a globe hologram that's actually made with superfine water particles. This is a hologram table created by an Australian company called Euclidean. You can imagine how this would definitely enhance sharing in conference rooms and meetings. By enabling engineers to test out their designs in life-size scale, products could be checked for issues that may not have been visible until a physical prototype. Because people will presumably be touching fewer surfaces, these displays could help reduce the spread of germs. Some potential uses. Holograms could be used for interpretive displays. I saw this interesting article about a museum using holograms for their Holocaust exhibit. Thought that was pretty interesting. Engineering and design, like I talked about before. Medicine and research, that's major areas that these holograms could be used and are being used. For example, physicians can do screenings like colon cancer, heart conditions, without having to do them surgically. Consumer electronics, of course. This is the Hydrogen 1 phone that's coming out soon. I think the price tag is about $1,200. And advertising. This is a holographic ad that's actually in stores now. It's a soccer ball that spins around. Application education. There's a lot of ways that these holographic displays could be used. For one, students could work with other students, teachers, or experts remotely in what feels like face-to-face interaction. Instructors could deliver lessons to multiple classrooms across the globe simultaneously. Gaming would become much more immersive and allow students to interact with the environments they create. Students in classrooms or maker spaces could complete a design project in 3D and then maybe print it using a 3D printer. Holograms could allow students to conduct science experiments that would be too dangerous, too expensive, or too difficult to perform in real life. Students could go on immersive virtual field trips. And then, taking current tech education to the 21st century, holograms could train students how to do job-related tasks in different vocational fields. Some potential issues. Lots of these technologies are cost prohibitive, leading to selective enhancement and a widening of the digital divide between the have and the have-nots. There's also some concern with safety. As you can see here, holographic display comes up when somebody's driving. It's possible that these technologies could be owned by a specific company or companies that control and restrict access. This last one is sort of a nebulous concern people have with lots of emerging technologies, that we're becoming more isolated from each other and more connected to our gadgets. However, I think the sharing aspect of holographic displays does ameliorate this concern, at least to some extent. Okay, thank you for listening.